Hi everyone, welcome to your lesson on atomic structure, your first lesson in chemistry, which is our cycle of study for foundations. And chemistry is the foundation for so much of what happens in the world, including what you're made of. So atomic structure starts with, what did people think things were made of? And for a really long time, people thought that atoms were the smallest particles and that atoms couldn't be broken down into anything else. Scientists now know that atoms are actually made from even smaller particles called protons, neutrons, and electrons. Question is, how are these particles arranged inside of the atom? The protons and the neutrons are in the dense core, which means the heavy core at the center of the atom. This is called the nucleus. So the nucleus has a positive charge because protons are positive and neutrons are neutral. They don't have a charge. So just like we're learning or have learned in math, when you take a positive and a negative, one positive and one negative, they cancel each other out. But when you have a positive with the number 0, then you're going to have a positive number. And so the same works with atoms. When you have a positive charge and something with no charge, the charge is going to be positive. The electrons are really tiny and they don't really weigh much at all. And they live on the outside of the atom in things called shells. Electrons have a negative charge. So the electrons circle or orbit the nucleus in shells or different layers. Okay, so now there are some things to look at with the periodic table, and we are going to do a cycle-long study of the periodic table, and it starts with atomic number. The atoms of any element always have the same number of protons. For example, hydrogen atoms always have 1 proton. Carbon atoms always have 6 protons. Magnesium atoms always have 12 protons. And if you look at the periodic table, the number that goes in order starting from left to right tells you the number of protons. That is the atomic number. So if you look for C, for carbon, you'll see the number 6. That's the atomic number, telling you carbon has 6 protons, and if you notice, no other element has 6 protons, and that's what makes each element unique. It's kind of like their thumbprint. No two people have the same thumbprint. No 2 elements have the same number of protons. So the number of protons in an atom is known as the atomic number, and it's the smaller of the 2 numbers shown in most periodic tables. So if you look, carbon has the number 6. The big number is, we'll get to that in just a second, the number 12. So let's practice really quickly. What are the atomic numbers of these elements? Sodium. Remember, you're looking for the smaller number. Sodium has 11 protons. How about iron? Yep, 26. How about tin? 50. And fluorine has 9. Now, the smaller number, or the atomic number, is not always going to be on the bottom. It can be anywhere in that square. So it's really important for you to remember that it's the smaller number. On very, very, very rare occasions, the number of protons can change. That means it's now a different element. This happens with radioactive decay and nuclear bombs / reactors. So, the mass number. We're going to learn about the bigger number. Electrons have a mass of almost 0. They're very, very, very light, which means that the mass of each atom comes almost entirely from the number of protons and neutrons in the nucleus. So you add up the weight of the protons and the neutrons, and that's the mass. That's how much the atom weighs. The sum of the protons and neutrons is the mass number, and it's always the larger of the 2 numbers shown in most periodic tables. To calculate how many neutrons there are in an atom, so if we know that 24 is how many protons plus neutrons, and we know that by looking at the atomic number, the little number, there's 12 protons, we know that 12 out of that 24 is protons. So whatever's left over, that has to be neutrons. So another way to do it is simply subtract mass number minus atomic number. So 24 minus 12 is 12. So hydrogen has 1 proton. It doesn't have any neutrons, therefore the mass is 1. Lithium has 3 protons, 4 neutrons. You add those up, therefore the mass number is 7. And we're estimating here. Okay, so we're rounding up. Sorry, not estimating, we're rounding up. So lithium really has like 6.99, we're rounding up to 7. Aluminum has 13 protons, 14 neutrons, which has a mass number of 27. Again, mass number equals number of protons plus number of neutrons. And here's some more practice. How many are you going to get? 4. Copper. You would add them up. So again, the number of neutrons, you just subtract out the number of protons. So if we start with the mass, and we know the atomic number, which is the same as saying protons, is 2. 4 minus 2 is 2. Fluorine has 19, has 9 protons. 19 minus 9 is 10. And here's a couple more examples for you. Okay, now how do we calculate electrons? Every atom has a neutral charge, so must have equal numbers of protons and electrons. So remember, neutral is the same as saying 0. And so if we want to get a number 0, and we have positive numbers and negative numbers, our integers, you would take positive 3 and negative 3 and add them together, and they cancel out. So because every atom has no charge, you have to have equal numbers of protons and electrons. So what that means is if you know the number of protons, you also always know the number of electrons because they're equal. So notice, 29 protons, 29 electrons. 53 protons, 53 electrons. So atoms can lose or gain electrons, but that is in another level chemistry class, and those are called ions. We are just going to be dealing with atoms that have a neutral charge or no charge for this chemistry class. If you want to do an extension on ions, you are more than welcome to submit a proposal to do an extension on that, and I would be more than happy. So, the arrangement of electrons in shells is called the electron configuration, and each shell can hold a certain number of electrons. The first shell, which is surrounding the nucleus, can hold 2 electrons at most. The second shell can hold 8, and the third shell can hold 8. So the rule is 2, 8, 8. Okay? 2 in the first shell, 8 in the second, and 8 in the third. And we're going to be doing a lot of practice with. So how to make a Bohr model using helium? You would use the periodic table to determine how many protons, neutrons, and electrons. Then you would draw a circle and label the number of protons and neutrons in the inside of the circle representing your nucleus. Okay, so helium has 2 protons, 2 neutrons. Then you draw your first shell around the nucleus. Okay, and it has 2 protons so that it has to have 2 electrons. You would plot them in, and if you needed to add more electrons, you need to add another shell.